9.5 wave interference Young double-slit experiment. If light has wave properties, then two light sources oscillating phase should produce a result similar to interference pattern in a ripple tank, right? Light should be brighter in area of the constructive interference and it darkens in the area of the destructive interference. Here is the two source of light. The solid line tell you maximum, and we have if two maximum is interfere from one source and the other source, it would be a bright point will be formed, and we will have a constructive. If the minimum and maximum interfere, we will have a destructive interference, as you see, it's dark. Here is, we have a source, we have a two opening here. When there's a source coming and the wave hit this opening, these openings individually act as a source. It's like we have this source here and we have another source here which produce a pattern, and you will see the interference pattern here. You see the bright, which is your maximum, use the dark, which is the noodle point. Before we see that the sine theta is n minus 1 over 2 lambda over d, when n is 1, 2, 3, this gives you a destructive interference, the dark or the noodle. And sine theta is equal to m lambda over d will give you constructive interference, give you the bright points. So this is constructive interference. And you know that the sine theta is xn over L. Xn is the distance of the point to this bisector L. You can see that this side and this side we can approximate to be the same if these thetas are very small. The L here and this will approximately be the same. So x or L is tan theta. However, the sine theta will work as well. The L is much more larger than x. And you know, d is the distance between the two sources, lambda is the wavelength. Okay, if you just put n to be 1 in this destructive interference, and you solve for xn, if the n is 1, we have L lambda over 2d, x2 is 3L lambda over 2d, x3 is 5L lambda over 2d. x2 minus x1, if you do that, you will get lambda over d. Also x3 or x3 minus x2 will get lambda over d. Therefore, just you will note that delta x is the distance between two adjacent noodle points divided by L is equal to lambda over L, lambda over d. See, this is delta x, the distance between two successive noodle points. It's the same everywhere. Okay, so look at this question. You are measuring wavelength of light from certain single color source. You direct the light through two slits, so it's double-slit experiment with a separation of 0.15 millimeters. So D is given 0.15 millimeter. You can convert it to meter. And the interference pattern is created as 23 meter away. This is your L. You find distance between the first and the 8th consecutive dark line is 8 centimeter. So the first one, 1, 2, 3, 4, 5, 6, 7, 8, right? Between here and here is 8 centimeter. It means your delta x is 1, 2, 3, 4, 5, 6, 7, right? So 8 is equal to 7 of those delta x. So we can find the delta x, approximate that to be 1.14 10 power negative 2 meter. At what wavelength is your source radiating? Since we know that the X over L is lambda over D, we are looking for wavelength. So range for wavelength is D to the other side. D is given. Delta X we found it there, and L was given 3 meters. So we just find the wavelength. Here the third order dark fringe. So third order dark fringe means N is equal to 3. Of 652 nanomillimeter light is lambda, so your wavelength. Observe at the angle of 15 degree. The theta is 15. When the light falls on two narrow slits, how far apart are the slits? We're looking for D. That's for destructive because it's a dark fringe. N we know is 3. Lambda is given. The D you want to find theta is given. So just rearrange it for D. You find D to be this. You can practice number 1, 2, and 3